Hi everyone, this is Dr. Getsi from the Department of Computer Science and Engineering RIT, and in this video we are going to discuss about the conversion process of push-down automata to its equivalent context-free grammar. Right. So for this problem, they will be giving you a push-down automata. Usually we represent the push-down automata as 7 tuples. Right. The set of states, set of terminals, set of stack symbol, then delta, that is the transition, initial state q naught, and initial stack symbol z naught, and the final set of final states. So usually the set of final states or the push-down automata either will accept the string by empty stack or find a set of reaching set of final states. See here it is accepting its language by empty stack, so that is why we have left it as a empty curly brace, right. So for this we know that the grammar is, that is the context free grammar is represented as v equal, that is g equal to v, t, p and s, that is set of variables, then t set of terminals, and p set of production rules, and the start symbol s, right. So we are going to frame one by one, and already we know t, right, the terminal set. So in the problem itself, in the question itself, they have given us the set of terminals are 0, 1, and also they have given s as the start symbol. We know that s is the start symbol, and now our task is to frame the set of variables v and the set of production rule p. So this is what we are going to frame now. So we are going to prepare the set of variables v. So by default the set of variables v contains s as one of its elements, right. S is a start symbol, so by default S is a variable, right. So it is non-terminal, so we can include S in the variable set, and the rest of the variables we are going to frame here. See, the rest of the variables, we are going to represent each variable in a triplet form. That is, it is going to have 3 components: first component, second component, third component. The first component and the third component are going to have states q naught, some states, the PDA, and the second component represents a stack symbol. Let us take Z or capital X or capital Y like this. So we are going to represent each variable in a triplet form, so consisting of 3 components. The first component and third component is going to represent the set of states, and the second component is going to represent a stack variable, right. So for this we are going to frame, right. See, the given push-down automata consists of 2 states, q naught and q1, right. For these two states we can frame 4 combinations, that is q naught, q naught, q naught, q1, q1, q naught, and q1, q1, right. So for these combinations we can put these combinations in the triplet form: q naught, q naught, q naught, q1, q1, q naught, q1, q1. So we can place it, and the second component can be filled as the stack symbol. So the given PDA consists of 2 stack symbols, z naught and x. So the first combination can have z naught in its place, and the second set can have x in its place. So here this is what the variables, capital S, here q naught, q naught, q naught, q1, q1, q naught, q1, q1. So all these sets we have placed z naught in its second component. Then the rest of the sets, that is q naught, q naught, q naught, q1, q1, q naught, q1, q1, we have placed x in its middle, right. So this is what the set of variables, right. So G equal to V, T, P, a set of variables here framed. Already we know the set of terminals. Now the most important thing is we have to frame the set of production rules. This is what the most important thing here, right, production rules. So the fourth component is S, capital S, that is the start symbol, as we know. Now we are going to frame the production. Now let us frame the production rule for start symbol. So the start symbol here is S, capital S, right. So for the start symbol we are going to frame the production rules. So here in this automata, set of states are q naught and q1, right. These are the set of states. So let us start framing the rule, and here as we told, each variable is represented as a triplet, right. And since we are using the square bracket, there is no need for putting comma in the in splitting this component, right. So, in the first component it is going to have q naught, since q naught is the initial state, and the second component is usually going to have the stack symbol, and here we are going to place z naught, since z naught is the initial stack symbol. See, from the question itself they have given, right. So, in the question they have given us z naught as a start symbol, initial stack symbol, and q naught is the initial state. That is why we have given us q naught and z naught, because we are framing the rule for the start symbol. So, start symbol is, has to hold all the initial values. So, q naught is the initial state and z naught is the initial stack symbol. Now, we have to fill this component. So, this component is going to have all the possible states. So, here the given PDA consists of only two states, 0, q naught and q1. So, you can place q naught first, and in the next production S implies the same thing, q naught, z naught and q1. So, among these three components, first two components are going to be the same, it is not going to be changed, and the third component are the all possible states, q naught and q1. So, as of now we have framed rules for the start symbol, right. And the next is we have to frame the rules, that is production rules, for each transition given in the PDA. So, in the given PDA, look into the transitions, right. So, here are the 6 transitions available, and among these 6 transitions, the first two transitions are performing the push operation, right. See here, from the state q naught, if the input 0 is given and z naught is the initial stack symbol, then it goes to q naught, and ultimately the capital X, that is another one more stack symbol, is pushed onto the stack X, right. Same in the second one also, q naught 0 X, one more X is pushed onto the stack. So, the first two transitions are performing the push operation. The rest of the four transitions are doing pop operation. So, this can be clearly identified from the symbol epsilon here. So, the epsilon represents, this epsilon represents the pop operation, right. So, usually epsilon represents the empty string, here this epsilon represents the pop operations, right. So, we are going to frame production rules for differently for the push and pop operations, right. So, let us see for the push operation first, right. So, let us see if the first transition is q naught comma 0 comma z naught, it goes to q naught and x is pushed onto the stack, right. So, let us write this transition here. So, for this transition, the transition is del of q naught comma 0 comma z naught is equal to q naught comma x z naught. So, when the push automata accepts 0 as the input in the states q naught, x is pushed onto the stack. This is the transition. So, for this transition we are going to write the production rule. So, from where it starts, q naught, put q naught here, right. So, when it starts, what is this top stack symbol, that is a stack symbol of the at the top, z naught, right, q naught z naught. So, inside the triplet you have to give. So, one more element has to be filled, leave it now, q naught z naught, leave the third component. Now, it produces, what is the input given, 0. So, that has to be written here, 0, right, 0. And now, and what is the next one is, here where it goes q naught, right, it goes to q naught. So, fill here q naught, and this we can erase it. Right. So, q naught, here there are two stack symbols, x and z naught. So, for x, put x here and insert a new variable and put z naught here, right. So, if there are one more symbol here, you have to place one more variable, right. So, for this 0 q naught x, Okay. So, here this component has to be filled with all possible states of the given PDA. So, for the given PDA consists of two possible states Q0 and Q1. Let us fill it as Q0 first, and one more production is Q0, Z0, Q1, right. Here also the same. Okay. Now, fill the first one. See, if Q0 is present here, the same should be returned here also, Q0, the last one, Q0, and whatever you write here, the same should be filled here. So, if you put Q0, the same should be written here also. So, there are two possible states. So, Q0 is one possibility, another one possibility is Q1. So, add one more rule. So, R 0, the same Q0, X, Q1, instead of Q0 you place it as Q1, write it as Q1 and here also Q0. And for the next one, see here the same thing 0, where it goes Q0, X, the same Z0. Here you have to fill it as Q1. So, here it is Q0. Another one possibility is 0, Q0, X, Q1, right. So, as of now we have framed the production rules for the first transition, right. So, there is L of Q0, 0, Z0 is equal to Q0, X, Z0, okay. And now we are going to frame the production rules for the second transition. The second transition is del of Q0, 0, X is equal to Q0, X, right. So, from the state Q0, when the top of the stack contains X and when the input 0 is given, it transit to the same state Q0 and one more stack symbol capital X is pushed onto the stack. This is what the transition tells, right. So, here and for the next transition, del of Q0, 0, X is equal to Q0, X. So, for this transition we have to frame it as from where it starts Q0 and when it starts what is the top symbol, top stack symbol X, and so we are going to write 2, that is Q0, X. Here you can fill Q0 and here you can fill Q1, right. So, what is the input given here? 0, where it goes Q0 and what are the top stack symbols X and X, right. So, here this is Q0 and if you put Q0, one more possibility is there. So, you can fill it as 0, Q0, X, Q1, X, Q0, and similarly you can fill here also 0, Q0, X, Q0, X. The only thing vary is Q1 and here also 0, Q0, X, Q1, X, Q1. The only difference is here Q0 you will be putting here Q1. So, as of now we have framed the transition, that is production rules for two transitions, right. And the rest of the transitions are very simple, that is performing pop operations, right. Pop operation is very simple. Okay, you can write it here. So, for the third transition you can write it as, so it starts from Q0, right. So, when it starts the top of the stack contains X and where it goes Q1. So, upon receiving which input it goes to Q1, 1. Similarly, for the fourth one. So, where it starts Q1 and when it starts what is the top of the stack symbol X and where it goes Q1. Upon receiving which input it is performing, it is transiting 1. And for the next one, from where it starts Q1. So, when it starts what is the top stack symbol X, where it goes Q1, upon giving input epsilon. And for the last one is Q1, right, Q1 and Z0, the stack symbol is Z0, where it goes Q1, upon receiving epsilon it goes to Q1, right. So, we have completed all the production rules for all the transitions, right. So, from this set of production rules you can eliminate the unreachable symbols and also useless symbols, right. So, before before that you can replace each triplet as by a single non-terminal. Let us take capital A implies Q naught Z naught Q naught. So, let us take it as capital A and Q naught Z naught Q1 is taken as capital B, right. So, likewise you can replace the triplets by a single variable, and you can simplify the grammar by removing the useless symbols and also unreachable symbols, and after removing you will be getting a simplified grammar, that will be your result, right. So, this is how we can construct the context free grammar